What if we could build a nuclear battery the size of a hockey puck that powers your phone, your home, even your car? Not for hours, not for days, but for decades. This isn't science fiction. It's called the Millar liquid tritium power cell. And today, we're going to show you how it could change the world. Transition real world problem setup. Clips of solar panels, wind turbines, electric cars. The world is racing toward clean energy. But there's a problem. Current batteries wear out. Solar and wind aren't always reliable. Nuclear reactors, too big, too risky. But what if we could unlock a completely new way to store energy? Tiny sealed power cells based on safe, stable nuclear physics. Scene transition, animation of tiny glass tubes being filled and coated. Meet the Millar liquid tritium power cell, or LTPC for short. It starts with something called tritium, a special form of hydrogen. We take tritium gas and compress it into tiny quartz tubes about the size of a pencil lead. These tubes are sealed forever, safely locking the fuel inside. When tritium decays, it releases tiny particles of energy called beta particles. We wrap the tubes in advanced graphene coatings to capture that energy as electricity. Then we surround the entire structure with a layer of thorium, boosting the output even further. Side-by-side comparison animation, key fob versus LTPC capsule. A typical tritium key fob you can buy today produces just a few microwatts, barely enough to make it glow. But with this new design, the same sized capsule could produce nearly 100 milliwatts of continuous power, 200,000 times more energy. And it never needs to be recharged. Bundle 100 of these capsules together, and you've got a hockey puck-sized power module producing nearly 10 watts of energy, non-stop for decades. Scaling up, car battery, home power wall, industrial grid systems appearing. Scale this technology up to the size of a car battery, and you could power a small home or an electric vehicle. Scale it even further, and you could build off-grid power stations, emergency backup systems, or deep space probes that never need refueling. Seen how it matters. Footage of remote sensors, military equipment, satellites, disaster zones. This isn't just about convenience. Imagine powering remote military equipment, underwater sensors, Arctic research stations, or spacecraft on the edge of our solar system. No solar panels, no refueling, just stable, long-life, compact power. The technology to build this already exists. Quartz tubes, graphene coatings, and beta-voltaic energy harvesting are all proven science. What's missing is putting it all together, scaling it, and proving it in the real world. What if we could build a nuclear battery that lasts for decades? What if the future of clean, portable energy was already in our hands? We believe it is, and we're building it right now. This is the Millar liquid tritium power cell, and this could change the world. Subscribe for more future tech explorations, and let us know in the comments, what would you power with a battery that never dies?